Okay, to get us started today, we're actually going to use our calculators for a moment. So we're going to start talking about evaluating things using inverse sine, cosine, tangent, etc. So like your arc ones. So the first example in your notes, if you want to pull it out, asks for cosine inverse of negative 0.4. I asked for it in radians, that's what your homework asked for first. So make sure that your calculator is in radian mode. And then using this calculator, you're going to go for second and then down to that pi where it gives you trig. And if you keep going down the list, it lets you do cosine inverse of negative 0.4 and it gives you the response. Similarly, so we'd write down 1.98. And we could similarly do the same thing with cosine inverse or arc sine or inverse sine. And put a 0.23 and we get that answer. So let's turn to our notes and start writing some things down. So our first answer here was, we're going to the nearest thousandths, so that's 3 decimals, so 1.982. And then arc sine was 0.232 for arc sine. Okay, cotangent's interesting. So remember, cotangent is 1 over tangent. So we're not going to do 1 over tangent inverse, but it's really saying, hey, that ratio, this is equivalent to tangent inverse of 1 over negative 2, right? The ratio we're going to plug into inverse tangent is negative 1/2. Be careful here, if you end up doing like 1 over tangent inverse of negative 2, that's not going to give you the same thing. So go ahead and type that in your calculator, and we end up getting negative 0.0464. Same thing with cosecant. That's 1 over sine. So we've got to do sine inverse, but then we've got to flip this fraction to be negative 3/2. So remember, it's not the same as 1 over sine of negative 3/2. So now we go ahead and do our inverse sine of negative 3/2. And we end up with negative 0.72. Actually, there's a 9 after that, so we're going to call it 73. Okay. The next thing they have us jump into is they have us look at these inverse functions and talk about domain restrictions. We kind of ran into a few of these customers. Sorry, I just got a text that said customers. It had nothing to do with this. So it ends up having to be with a few of the problems we did in our previous ones in regards to the domain. So in the domain, think about, we're talking in this case about these restrictions. I was going to have us go through, but since we're online, I think you can look back at your notes or refigure that out. You will have to be able to kind of figure those things out yourself when given a test. But for now, I just put it there for us to refer back to. But remember, for something like sine, think about the graph of sine. And since, we want it to be 1 to 1, maybe we extend it more this way, and then we take the section, which ends up being from negative pi halves to pi halves as a domain, but then those y values are negative 1 to 1, and since the inverse it switches, hence the negative 1 to 1. So as we think about domain, remember that's your x values, right? So if you think about like A, for example, it says cosine inverse or arc cosine of 5 x, think about that 5 as having to do with something horizontally, right? And so anything inside the parentheses is something horizontal, right? Even if I add something weird like, hey, we shifted pi halves outside, that's not going to affect the domain at all. That would affect the range, so it's shifting it up. So as we think about that inside, usually our domain is for inverse cosine is negative 1 to 1. But we're really saying, hey, what did we do with that? We did 5 times that x value. And remember that you can think about that 2 ways. That's really actually doing the opposite of 5 times it. So it's like x divided by that. Or you can think about setting 5x equal to negative 1. So x equals negative a fifth. and 5x equals positive 1. So x equals positive a fifth. So our new domain, this is our original one, our new domain is going to be from negative a fifth to positive a fifth. And as you think about that, it makes sense because if we're doing 5 times those values, we'll end up back at our original domain. So even with tangent, same idea. You think about taking the original domain, and in this case, rather than multiplying by 4, we would divide by 4. But your original domain is all real numbers. So even if we think about taking negative infinity and dividing it by 4, you still get negative infinity, right? Same thing with infinity. Infinity divided by 4 still gives us infinity. So your new domain is still going to be negative infinity to infinity. Even as we continue on and we look at arc sine, so the inverse sine, we get 2x squared. Your original one is from negative 1 to 1. I would honestly think about setting 2x squared equal to negative 1, because that, I think it will help you with operations. Do we undo the squared, or would you undo the multiplying by 2 first? We undo actually the timesing by 2, so we get x squared equals negative a half. And notice here, that's not going to work out too nicely for us, because if we take the square root of a negative, we get imaginary numbers. So that doesn't work out. However, if we do the same process and set it equal to a half, we get x squared equals positive a half. And then we take the square root, sorry, I just wrote a fourth, of both sides. And to remember, there should be 2 answers here. This one actually gives us our positive or negative. Square root of 1 is still 1 over the square root of 2, or you could call that square root of 2 over 2. So therefore, our interval is going to go from the positive and negative of 1 over the square root of 2. And as we square both of those and multiply by 2, we'll end back up at our original interval. Okay, we got just a couple more to take a look at. As we look at tangent, recall your original is all real numbers. Sorry, inverse tangent. The domain is all real numbers. The issues we're going to run into here is natural log. And if you guys remember from 1050, we can only plug in positive things. So the whole idea here is that this must be positive. So it's not actually the original one that's giving us restrictions, it's what they inputted there. So if that must be positive, 2x minus 1 has to be greater than 0. The question is, can it be equal to? And in case you're wondering, I mean, like, you can always remind yourself by typing like natural log into your calculator of 0 and seeing if that gives you a domain restriction. But it does, so it cannot be equal to. 2x is greater than 1, so x has to be greater than a half. So we're not including a half, and then if it's greater, it will go all the way to infinity. Okay, same thing here. Arc cotangent, if you remember from up here, it tells you that the domain is all real numbers. So you'd think, oh, hey, it could just be all real numbers again, kind of like we did before. However, we run into problems here when we're taking the square root of something. Recall, when you take the square root, what kind of numbers do we not want underneath? Negative. So therefore, what's underneath there, right, the 2x minus 1 has to be positive. However, this time, can it be equal to 0? Can you take the square root of 0? The answer is yes, so it could be equal to. Notice we have almost exactly the same problem as up above, but now it'll be x is greater than or equal to a half. So the only difference between the domain of this and the last one is bracket a half to infinity. Last but not least, secant. So secant's a little bit funny. If you look back up here, remember it's the one where it's like basically anything besides negative 1 to 1. So if your original is from negative infinity to negative 1, and then you do union 1 to infinity, think about how 12x will impact that. What did we do in the other problems? Well, to undo that 12, we divided by 12. So if you think about dividing each of those parts of the interval, negative infinity divided by 12 is still negative infinity. Negative 1 divided by 12 is going to be negative 1/12. As far as your parenthesis and bracket, that won't change at all. Same thing on the other side. 1 divided by 12 is a 12th. 12 divided by infinity is still infinity. All right, I'm going to pause there for this video, but then I'll pick back up with the application.